All right, I'm going to go ahead and get started. I'm recording this and I will post this on my YouTube channel for you to reference later should you need to, and then for other students as well. I have a feeling this is not a good time since nobody showed up last week and I have just 2 today. So if there is another time, please feel free to you can type that into the chat if there's a day time that would work better for you. Or if you know other students that would prefer another time for this, I'm going to put my email address in the chat. That way you can reach out if you need to. During this review or this intro, if you have any questions, please feel free to unmute or just type into the chat and let me know what your questions are. So what I'm going to start off with is just, you should have already seen this, which is your blueprint for your drug calc test, which I believe is week 6, week 7. And this just goes through the different rules associated with the different things to know about in general. But I will point you down to here. This is the arrangement of the questions that you'll see on your test. You'll need to know how to do household to metric conversions, metric to household conversions, metric to metric conversions, and you'll see questions associated with that. And we'll go over a couple of those today. You're going to need to know some standards for what those conversions are. And we'll talk about that as well. You're going to need to know how to go from pounds to kilograms. So you'll see that. You'll have a couple questions on intake and output. And I think it's predominantly intake for you guys, meaning you'll see an example question, but basically patient receives, certain amount of food, and the volume of food that they bring in, you're going to calculate that and convert it to milliliters. So we'll talk about that. Oral meds, that can be both tablets, capsules, as well as milliliters, suspension type medications. The parenteral medications, meaning that those are injectables, so subcutaneous and intramuscular. Those are also going to be milliliter type questions. You'll have 2 reconstitution questions, and that's a fun thing with the first time you see that. But then after you see it and know how it works, it's usually you can navigate through it. And then some insulin dosage questions, which is really just can you read a scale, a sliding scale, which is pretty straightforward. So I'm going to go ahead and I'm going to switch over to the review. There we go. All right, so there's some practice problems. Now, before I get to this, actually, let me pull up one more thing. I don't need to pull this up. I can actually pull this up in another thing here. I'm just pulling up some conversion factors that you need to know. That way I have them written up there. All right. All right, so these are the conversion factors that you need to know and have memorized. So you need to know that a gram is 1,000 milligrams, A milligram is 1,000 micrograms, a liter is 1,000 milliliters, and on down. Some of the ones that are a little bit more tricky, sometimes just the ones that are involved like cups to ounces to milliliters, pints to cups to ounces to milliliters. And so you need to know how to work with these. And my hope is that I can show you just, and then with some practice, you'll be able to get through these. All right, so couple things. We'll do some of these practice problems here. So I put a bunch of these. This is not how your test will look, but there's a bunch of just questions, and I'll kind of start working through a few of these. And then we'll get into some of these like other like fluid type questions. Again, and you have access to this. This is in that OneDrive folder. If you go in there, I think one of them I labeled already 23 spring. But this one is going to be just the standard one. So it should be there might be some nuance to the 23 spring one that I started writing in, but this will just be a good starting place. All right, so what I'm going to do is I'm going to create some spaces. So I know, or at least I think I know, that at Boyce, you don't need to necessarily follow one particular. Oh, go ahead. What's your question?
So I just wanted to know, do you normally, whenever you have these meetings, do you do the same, do you like do the same questions, or do you have like different type of activities that we can go over on each of the Zoom calls that you do?
Okay, good question. So so each, I'm just going to pause. All right, so what I'm going to do is I'm going to just work through a few of these problems just so you can kind of see the style. I always say that these first, like when we're doing these basic unit to unit conversions, and I say basic because you should have seen this in biology, you should have seen this in chemistry, but if it's been a little while, don't worry, we've all been there. And we want to try and make sure that you're getting the information that you need. So what I'm going to do is I'm going to predominantly show you via dimensional analysis how I would set up these problems. And the reason I utilize dimensional analysis is because it will help you out later on down the road when you encounter problems that don't follow or fit the ordered over have kind of structure, or the ordered or desired over have structure, if that is the particular model that you follow. So so I'll use that, but I also know there's more than one way to answer these questions. The important thing is that you're getting your answers and you're answering them correctly. Like when I look at number one, I can tell you from like just looking at it, I know that the answer is 1.375 grams. I don't have to do anything. I don't even spend much time thinking about that. Now, if you're there, great. But if you're not there, let me show you how you can make sure you get it right every time instead of hoping or guessing that you're getting it right. So what I'm going to do is I'm going to take that 1,375 milligrams. I'm going to put that over 1. And what I'm going to do is I'm going to create a conversion factor, and I'm going to convert this from milligrams to grams. Now, in order to do that, I need to already know that there is a way to convert milligrams to grams. And if we scroll up or we go back to the beginning of this, we can see that 1 gram is 1,000 milligrams. So that's how they're related. Okay. So I'm going to come back here. Before I do anything as far as solving this problem, I'm going to just put my units where they need to be. The first question the next question I ask myself after I've asked, do I know a conversion? Yes. The next thing is, what am I trying to get rid of? I'm trying to get rid of milligrams. And what am I trying to convert to? Grams. Okay. So before you do anything, you'll know that you've arranged it correctly just by looking at the units. So you don't even need to worry about numbers necessarily yet, but we already have the 1375 there, so we're going to work with it. The next thing is we're going to look at is the conversion factor. 1 gram, 1,000 milligrams. The trick to this is just to put it where it goes with the number. If this is new to you, if this is something that you struggle with, and then even if you don't utilize this technique, if you ever get stuck, I can almost promise you that using dimensional analysis will help get you or help you to figure out how to answer the problem if, like I said, if you ever do get stuck. So I'm going to take that 1,375 times 1, and then I'm going to divide by 1,000, and that's where I'm going to get my answer of 1.375 grams.
Okay, so I have a question. So where are you getting the decimal from?
What do you mean?
The decimal, the 1.375, where is that coming from? Is that coming from when you're dividing 1,375 from 1,000?
Correct. Yeah. So when you type into your calculator 1,375 divided by 1,000, you'll get 1.375.
Okay.
Yeah. And then you should know that on your test, you will have a basic 10 key calculator. So you're allowed to use a calculator on this.
Okay.
All right. So let me give you.
I'm sorry. And one more question. So this method, what you just did for the conversion from milligrams to grams, like this will work for any conversion from milligrams to grams.
Correct. Yep.
Okay.
You're pretty much anytime you're going from milligrams to grams, you're dividing by 1,000. That's the shorthand of it.
Okay. Thank you.
You're welcome. So let me give you a practice problem. So let's say we had 265 milligrams, and I want to know how many grams that is. So go ahead on your own, try and solve that problem, and then just type in your answer into the chat if you can. If not, you can just speak it out. All right, so your number is correct, but
Yeah, I'm sorry. I meant to put grams. I'm sorry.
Okay, that's fine. Yeah, just make sure you use the correct units when you are when you write your answers and things like that. Yeah, you're fine. I figured that was the case. And then I always tell people this is the place to get your answers wrong. Also, don't forget the 0 in front of your 0.265. Okay. But yes, if you got 0.265, you did that correctly. 265. What about the reverse? What if I have 0.25 grams and I want to know how many milligrams that is? So I'm actually going a different direction. So go ahead and see if you can figure that one out or solve that one. And same thing, just write your milligram answer in the box, and then I don't know is an acceptable answer. Good job. Yep. Yeah, if you got 250 milligrams, that's exactly what I got. So for practice purposes, let me just set that up. So this is going to be a little bit different, but I'm going to follow the same methodology. The difference is I'm going to put my milligrams and my grams in the opposite spots. So in this scenario, what are we converting to? Milligrams. What are we trying to get rid of? Grams. Do we know how to go from milligrams to grams? Yeah, 1 gram, 1,000 milligrams. So again, this starting with the units first tells us which way to go or how to arrange everything. And then we know we're multiplying by 1,000 versus dividing by 1,000. Now, if you have another way, or you just kind of do it like I was telling you at the beginning here, I just look at it and I know what the answer is because I've done these types of questions before, and then that might be your experience as well. Going through this and doing this when it's simple usually helps out later on down the road when it becomes a little bit more complicated. Okay. So I will leave a few of these just kind of for you to work through. I'll let you work through the micrograms to milligrams and then on your own. But I'm going to go ahead and jump to the next thing, and we're going to go ahead and do pounds to kilograms. Now, you do need to know how to go from kilograms to pounds, but I would say that in nursing, the most common conversion is you're going to take the patient's weight in household units, pounds, and convert it to kilograms. And you might be wondering, well, why in the world are we doing this? Well, some medications are going to be administered via, they're going to be considered weight-based medications. So we might want to only give 5 micrograms per kilogram body weight. And so we need to take that into account. So if we have someone that's smaller, lighter weight, they're going to get less medication. And then someone who's larger might get more medication. That way they get more of an effective dose. You'll touch on that a lot more when you get into, I think it's either 220 or 230. You'll cover pediatrics. And then you'll do pediatric dosage calculations. And that's where you'll see a little bit more of this, what I'm talking about now, which is the weight-based calculations. You won't see that for necessarily this semester, but I'd like to at least let you know what's coming down the pike. So one of the things you need to know is you need to know that 1 kilogram is equal to 2.2 pounds. So when you know that, and if you're doing the simple way for this is just 165 divided by 2.2, that's how many kilograms. Another way to remember it is when you go from pounds to kilograms, it's like you lose half your weight. Okay. And then when you go from kilograms to pounds, you double it. So, but if you ever get stuck, using dimensional analysis can be helpful. 165 pounds over 1. I'm converting from pounds to kilograms. Cancel out my pounds. 1 kilogram is 2.2 pounds. Then I'm going to plug into my calculator 165 divided by 2.2. And I'm going to get an even number of 75. Now, if I had gotten a number of like, let's say it was like 75.454545 repeating, we would round to the nearest 10th. So in that scenario, it would be 75.5. Go ahead and try converting 117 pounds to kilograms and let me know what you get. You got it. Yeah, and with the weight, the rounding, you did that perfectly. Okay, so remember, we want to round to the nearest tenth. So the 53.19, that's rounding to the nearest hundredth. So we don't want to do that. Plus, if you're going to round to the nearest hundredth, it would still be 8 because it was 0.181, right? If it was 0.185, then you could say 0.19. But remember your rules, and I know that we didn't really go over rounding rules, but the rule is when it's a number greater than 1, so 1, 2, 3, 4 point whatever, round to the nearest tenth. If it's a number less than 1, like 0.125, you would round to the nearest hundredth. So the answer to this would be the 53.2 kilograms. So make sure you round it to the nearest tenth. Now you might be wondering, well, why didn't we round, like when we did this 1.375 grams, why didn't we round that to 1.4? So the rule on that is when you're staying within the same metric system, so when you go from milligrams to grams or micrograms to milligrams, you do not round those answers. You keep them as they are. So you're just doing, when you're just doing this, the basic metric to metric conversion, do not round your answers. But when you're going from household to metric, such as pounds to kilograms, now you're going into different units. And then when you see on your calculator and it says 53.18181818, that's your clue to round to the nearest tenth. Okay, so there's a couple questions about pints, ounces, cups, and quarts, and that kind of just gets you ready for the fluid intake question that's down here. So with pints, let's just start off with cup. Okay, so I have to go back up here. Remember, we have a couple things. You're going to see this. You're going to have 2 questions that are going to ask you about calculating the fluid intake of a patient. So they're going to have like a selection of foods. You're going to be looking at the ounces of foods, most likely, sometimes cups, maybe a pint. And then you're going to have to convert that from the household measurements to the milliliter equivalents. So a cup is 8 ounces, which is 240 milliliters. And then if you look above where it says 1 ounce is 30 milliliters, that's where all that's kind of coming in. A pint is 2 cups. 2 cups is 16 ounces, and then 16 ounces is 480 milliliters. And then a quart is 2 pints, which is 4 cups, which is 32 ounces, which is 960 milliliters. And then just to put that in perspective, if you have a liter bottle of water, it's about a quart of water. Okay, it's a little bit more than a quart of water, about 40 mil more. And then if you've ever looked at a water bottle and looked at sometimes the water bottles have measurements on the side, it'll give you the cup measurements or ounces measurements, and then it'll give you the milliliters measurements. So just some ways to kind of put that in perspective. And then if you're ever looking at your coffee pot and you see those numbers, those are numbers of cups of coffee. And I believe a cup of coffee is technically 6 ounces. So just don't use your coffee cup to correlate with the cups that you need to know about for nursing and our household measurements. Another thing,
I have a question.
yeah.
Would there ever be a question that would ask about like the gallon as well? Like a gallon conversion to like quart or cup or something like that?
Okay, so that's a good question. I haven't seen anything like that, so my guess is no. Plus, if you think about it, like the question that they're going to ask you most likely is going to be, what's in front of the patient. Most likely, you're not, the patient most likely is not going to have like a gallon of juice that they're going to drink up in like for lunch. And so there is a possibility that you could have that. I don't think that is a possibility. But if I'm not mistaken, I think a gallon is 2 quarts. But let me just double check, or maybe it's 4 quarts. Sorry, 2 quarts. Oh, it is 4 quarts. So a gallon would be 4 quarts, which would be 8 pints, which would be 16 cups, which would be 96 ounces, not 96, 128 ounces. And then what is that in milliliters? We can write this out. Hold on. I'll make sure I get that all for you. 128 times 30 is 3,840 milliliters. So I don't think that they're going to ask you that, but if they do, let's just go ahead and write it out. 1 gallon is 4 quarts. Which equals 8 pints. Which is 16 cups. Which is 128 ounces. Which is, what did I say, 3,840 ml.
I am so sorry. I did not hear anything you said. My computer just completely froze on me. I'm so sorry.
That's okay. So I was just typing in the event that I don't think that they're going to ask you gallon to conversion, but I wrote it out for you just in case you do need to know it.
Okay, thank you.
You're welcome. So I don't think that you're going to do that, but if you do, now it's written, so you have it. All right, so let's practice some of these. All right. So let's start with cup. Actually, let's start with ounces because that one's the most basic conversion. So 1 ounce is 30 milliliters. So if I'm doing this and I'm following using dimensional analysis, I'm going to convert ounces to milliliters. And I know that 1 ounce is 30 milliliters. Ounces cancel. And I'm going to have 120 milliliters. Now, we'll say with this, with going from ounces to milliliters, keep in mind that we're talking about fluid ounces when we talk about this. We're not talking about ounces like pound ounces. And the reason I mentioned that too is like they might tell you that the patient had a 4 ounce, burger, or a 4 ounce piece of chicken, or a 4 ounce piece of steak. I don't know what hospital they're getting steak at, but 4 ounces. And that is weight, not fluid volume. And so that's important to know. So, because if they did give you that, I think it would be as a way to like make it tricky, and not necessarily to give you the answer that you're looking for. So, anyways, what I'm getting at is the fact that you're, you just, if you see like it tells you what type of food it is, make sure you know that it's whether it's a solid or a liquid, and it should be pretty apparent. All right. So that's ounces to milliliters. What about cups? So if we know that a cup, we know that 1 cup is 8 ounces and 240 milliliters, right? So I'm just going to kind of write that over here. 1 cup is 8 ounces, which is 240 milliliters. Now this says it's a half cup, okay? In a half cup, we're going to, for your question, that conversion would be different. Are you talking about for like going the meat ounces?
Yeah. As far as when you just said about the conversion from fluid ounces as different, it would be different from like weight ounces.
Right. Well, first of all, you wouldn't be able to do, there's not a conversion for weight ounces to milliliters, because they're two different. You'd be going from those ounces to pounds to kilograms. So you wouldn't be worrying about converting it. That's why I was saying, like, when you think about eating a piece of chicken, that's not fluid intake. So that's all I was saying is pay attention. If they tell you 6-ounce piece of chicken, that has nothing to do with, you don't need to calculate the milliliters for that, because the milliliters is approximately 0.
Okay, thank you.
You're welcome. All right. So half of a cup would be, everything would be in half, right? So a half of a cup would be 4 ounces. Half of that would be 120 milliliters. But let's say we wanted to just make sure we were doing everything right. What I would recommend you do is, you can do this one of two ways. You can write it as like one cup, over 2, or if you prefer, you could just say 0.5 cups over 1. I'm just showing you that you can do dimensional analysis with all these things. We're going to get rid of cup for milliliter. 1 cup is 240 milliliters. So if I do 0.5 times 240, I'm going to get my answer, which is 120. I'm going to do the same thing with pints. We can look at, we can say a pint is 2 cups, which is, what do we say? 480 milliliters. So let's just write that out. We know that 1 pint is 2 cups, which equals 480 milliliters. And again, sometimes it's helpful just to write these things down. If you don't have them memorized yet, just write them down. That way you can refer back to them and you'll get in the habit. It'll help you to memorize it, just writing them down. All right, so 1 pint is 2 cups, is 480 milliliters. And I'm gonna do exactly what I did in the previous problem. I'm just gonna set it up by taking the 1.5 pints over 1, and I'm gonna set it equal to a conversion factor. I'm gonna convert pints to milliliters, which I can do. 1 pint is 480 milliliters. So 1.5 pints is this equivalent, I believe, to 3 cups, but 480 times 1.5 should be 720. Yeah. 720 milliliters. So if you ever find yourself in the kitchen and you're preparing a meal or you're doing some measuring, pay attention to the cups and the milliliters and the ounces. A lot of times it's right there on the measuring, whether measuring cup or the measuring bowl, or whatever that, or even the teaspoons and tablespoons. Just keep an eye, or look at that as a way to kind of anchor what some of these things are if you are, having trouble with it. I'll let you work through the court one on your own, but let's look at this question 9. So this is what this would look like. So I'm going to say, I'm going to actually add this as 1 6-ounce turkey sandwich. Now that you know to look for that, and you know that doesn't mean what you think it is. So I'm just going to say a 6-ounce turkey sandwich. That way it adds a little bit of complexity. Okay. I don't think that they're going to add that to your test. But I think it'll be a good thing to get back and think about and question it. I also don't think they're going to do this, where they're going to do 1/4 of a glass, okay, of orange juice. It'll most likely just be 1 or a half, but as a challenge, I just kind of did that. So basically what we're going to do is we're going to calculate the total fluid intake, and they're not going to tell you what they're looking for. You need to know that you're looking for milliliters. And the reason you're looking for milliliters is because you're studying to be a nurse. Nursing is part of the medical sciences, and medical sciences uses the metric system. And so that's kind of like your clue in as to why you're using some of these things. So the first thing we're going to do is we're going to convert this 1/4 glass of orange juice, and it tells you that a glass holds 8 ounces. So it's 1 cup. Okay. So you can do this a couple different ways. You could just say, well, what's 1/4 of 8? And that would be 2. But if you don't feel good about that, let me just help you out. So 1/4, and you can even put this into your calculator, 1 divided by 4 will give you 0.25. So 0.25 glass. Okay. And if we're converting that, and we know that 1 glass is 8 ounces. So I'm just going to do this. I just want you to see where I get 2 from if it's not apparent to you. Would give me 2 ounces. Okay, so 0.25 times 8 would give me 2 ounces. And then all you have to do here is just, now that you have ounces, just multiply by the 30 milliliters. And then if you need to see it from a dimensional analysis standpoint, that's what that looks like. But for all these, you're just multiplying by 30. So the first one would be 60 milliliters of orange juice. 6 ounces of coffee, you're just multiplying by 30 milliliters per ounce, which gives you 180 milliliters. 6-ounce turkey sandwich, not fluid. So we're not going to make any kind of calculation here. So yeah, not liquid. Jell-O. You may not think of Jell-O as a liquid, but I'll give you a little clue. If they give you an ounce and it's could be a liquid, and if you think about it, if you've ever made Jell-O, Jell-O is just water and powder, and then you sit it in the fridge and then it congeals. So technically it's water, it's just in a slightly semi-solid state. So I'm going to do 2.5 ounces times 30 ml. And that's going to give me 2.5 times 30, 75 milliliters. And a 1/2 pint of chocolate milk. Well, we know that 1 pint is 2 cups. So a 1/2 pint is 1 cup, which is 8 ounces, which is 240 milliliters. So we can just write that 240 milliliters. And then all I'm going to do now is just add these all together. So 60 plus 180, and let me just go ahead and get my calculator out. 60 plus 180 plus 75 plus 240. And I'll have a total intake of 555 milliliters, which is about what? 2 cups, a little bit more than 2 cups, or a little bit more than a pint of fluid intake if we're going back to household units. So the trick here is just to pay attention to the solid thing, the sandwich, okay? Or it might be a piece of meat, a salad, all those things, because they will get measured in ounces as well, but it's weight ounces, not fluid ounces. If you ever buy a drink at the store, if you pay attention, a lot of times it'll say FLOZ, which tells you specifically it's fluid ounces. And then if you buy like packaged food, it'll say its weight is also listed in ounces. So that's where you have to kind of pay attention. If it's a solid substance, ounces, we're talking about weight. If it's a fluid substance, ounces, we're talking about liquid. So quantity of the liquid. I thought maybe I had an extra question like that, but I'll have to create a secondary question. All right, so that's a good place to kind of, stop discussion. Do you have any questions? Any other questions?
I do. So, do you post like an answer key to like these little practice questions that you do, or do you kind of post it after you do your Zoom call, like with everything marked off on here?
Okay, good question. I can't remember if I have a key to this. It doesn't look like I do. I can create a key Most likely though, you'll see the key get created as I'm working through these problems. And then the reason for that is because sometimes I change them, but I will I'll put in some I'll put a note in to myself to work on putting together a practice test with a key. That way you can practice these, make sure you're getting them right. And then that way you get some feedback. So I will work on that. But right now, no, I don't have one for you. If you go to the Allegheny folder, I have keys and practice tests for them. Their tests are a little bit different than yours, though. That's why I wouldn't necessarily tell you
there's some on Blackboard with Boyce, because before I left campus, I printed out a bunch of the stuff off of Blackboard that they had.
Yeah.
But I didn't kind of understand what everything was yet until now, since I'm talking to you. They had a bunch of the answer keys like this,